Alrighty, happy Friday everybody. This video might be on the longer side. You should have time to finish it in class, but just be aware we have like 4 or 5 pages of notes to get through today, so it's going to be a bit more than usual. But our new chapter, Unit 4, is all about triangles and congruent triangles specifically. So this first section is just about triangles, how we can classify them, how we can describe them, and what they may look like in practice. So before we get into that, just a quick reminder, even though I'm not here today, you are expected to watch this entire video, fill out your entire notes packet, so we'll get through page 5 today, and complete the homework on big ideas. So by Tuesday, when we come back, all of those things should be done. And in class on Wednesday, it's expected that you guys know all of these definitions that I'm about to give you, okay? So before we get into any of that, we have to do our algebra problem of the day, our warm-up. It says, write an equation of the line through the points -1, 3 and -5, 11. So anytime we need an equation of a line, we need 2 things. We need slope, m, and we need our y-intercept, b. So we go by finding m first. It's our y2 minus y1 over x2 minus x1. So I'm going to label these points, x1, y1, and x2, y2. Then I'm going to plug those points into my formula and find my slope. So y2 was 11, y1 was 3, so 11 minus 3 on top. x2 was -5, and x1 was -1, so watch your double negatives there. But 11 minus 3 on top is 8. -5 minus -1 is the same as -5 plus 1. That gives us -4. We simplify this down, we get -2. Okay. Now from Algebra 1, you probably learned maybe multiple ways to do this, but I'm going to teach you the way that I want us to focus on, and that they kind of changed the curriculum too, so now Algebra 1 is also only focused on this. And that way to do it is using point slope form. So if you remember this form right here, y minus y1 is equal to m times x minus x1, that is called point slope form. Point slope form. And the way we use it is once we have our slope, we take our slope and we take 1 point. So I'm going to use -1, 3. And we plug everything in and we get an equation back for our line. So I'm going to plug y1 and x1 in. So I get y minus y1 is 3, so y minus 3. My slope was -2, so m is -2. And then x minus -1. And again, just watching our variables here, or our negatives here, y minus 3, that's a double negative on the inside, so it's going to actually be -2x plus 1 after we, sorry, back it up. It's going to be -2, x plus 1. That we can then distribute. So y is equal to -2x. This right here would give me -2. And then I'll also want to add this 3 to both sides. So I'll have -2 minus 3. It's going to give me a +1. So our equation is y is equal to -2x minus 1. If we plugged in our other point into that equation, we would get a true statement, meaning 11 would be equal to 11 if we're using y2. Okay? So that's our algebra problem of the day, and now we're going to get into triangles. So first, we have our first definition of the chapter. There are a lot for this chapter, especially in this first section. So there will be a Quizlet made. It's not made quite yet, but once you come back from fall break, I will have a Quizlet up on Schoology, and we'll play our Quizlet live game, okay? But our first definition is a triangle. Hopefully we've all heard this word before. But if we look at the prefix tri, a triangle is a polygon with 3 sides and 3 angles, triangle. okay? So any polygon with 3 sides. A polygon is just a closed figure, meaning like something like this, anything that is closed, okay? Not like this where it's still open. Okay, the way we name triangles is we can either write the word triangle and then use all 3 vertices. The points on our triangle, on the corners essentially, are called the vertices. So we can call this triangle ABC. Or what you guys will see often is an actual triangle symbol, ABC. So this is the way that we're gonna do it in this class. We're gonna use the triangle symbol and then use the 3 vertices. On your test and in your homework, it's gonna ask you to classify certain pictures of triangles. And there's 2 different categories of classification that triangles fall under. We can classify triangles by their sides, meaning we can count the number of sides that are congruent, and depending on that number, we have a special name for that type of triangle. Or we can classify it by angles. And in that case, we'll talk about it in a second, but we're just kind of looking at our biggest angle measure, okay? But for sides, if we have no congruent sides, these are all just definitions that you'll have to learn and memorize. No congruent sides is a scalene triangle. So we call that scalene. 2 congruent sides, like this side and this side, is an isosceles triangle. Hi. Triangle type we'll talk about if we're classifying by sides is an equilateral triangle, and that is when all 3 sides are congruent. So the prefix equi usually means equal or congruent, and then lateral is sides or lines. So that's kind of where that comes from. We can also classify triangles by angles. We can either count the number of special angles, or an easier trick is just looking at the largest angle. Perfect, thank you.
Thanks.
Have a good weekend. So what we're gonna do is we're either gonna count the number of angles, or we're gonna look at the largest angle, and I'll show you kind of both ways. The first classification by angles, it's pretty straightforward. If all of our angles are acute, then it is an acute triangle. Okay? That also means your largest angle is acute. And if your largest angle is acute, all of the other ones have to be less than, smaller than them, so they also have to be acute. Next one is if you have one obtuse angle, or if your largest angle is obtuse, then you have an obtuse triangle. Okay, pretty straightforward. If you have an angle greater than 90 degrees, it's an obtuse triangle. If you have an angle that is equal to 90 degrees, a right angle, we call it a right triangle. And if you have a right angle, it will always be your largest angle. So really what we're looking for is we're asking ourselves, is our largest angle acute, obtuse, right, or do we have all congruent angles? Equiangular is what we call that. Same prefix, our equi prefix, and then angular for angles. So that's for all 3 congruent angles. So in that case, we kind of have to look at all 3 of them, because they could all be the largest until we look and see that they're all the same. Okay, so again, for acute triangles, your largest angle is acute. For obtuse triangles, your largest angle is obtuse. For your right triangle, the largest angle is 90 degrees. Okay, so what we do here is we name these by classifying the sides and then the angles. So we would say scalene obtuse, or an isosceles right triangle. Okay, so we're gonna classify these ones right here. First step, I'm gonna look at the number of congruent sides. Well, I see both of these sides are 4.8 and my other one is 6.8. So that means I have 2 congruent sides. So by our definitions, this is an isosceles triangle. Now I have to look at my largest angle. Well, I have 45, 45, and then I have a 90-degree angle. So this angle right here is my largest angle, and it's a right angle. So that means I have an isosceles right triangle. 2 congruent sides and 1 right angle. Next one. Again, look at the number of congruent sides. In this case, we have 3.6, 5.4, and 2.4. So we have no congruent sides. That means we have a scalene triangle. And now I have to look at the angles. I have 20, 31, and this unknown angle here. Soon, we will talk about what that unknown angle has to be. But for now, we're going to say it looks obtuse, so it is obtuse, and this must be a scalene obtuse triangle. Okay? Our very last one, again, number of sides that are congruent. This one has 3 congruent sides, aka all of the sides. So this is equilateral. And again, we'll learn this later, but any equilateral triangle is also equiangular. So this is an equilateral equiangular triangle. It's also called irregular. Polygons that have all congruent sides and all congruent angles are called irregular. So that means all of these other angles are 60 as well. And this is something you'll see often is 3 congruent sides and all 60-degree angles. Okay? So that's how we classify triangles. And now we're going to start talking about, some theorems with it and stuff like that. So, first, it says a side is opposite an angle. That means that every side has an angle that it's opposite to, and every angle has a side that it is opposite to. That side is the one directly across from the angle. So here's angle A. Angle A is opposite this side right here, side BC. And sometimes we even call the side opposite of angle A side little a. So you'll see this often, that angle A is opposite side A. AC, right here, if we go across, AC is opposite angle B. Also notice how the segment that is opposite the angle does not have the angle's vertex in it, meaning there's no A in this segment name, or there's no B in this segment name, because it's completely opposite. It's not hitting that segment at all. And then our last one is angle C. If we look here at angle C is opposite of, if we go right across the triangle, angle C is opposite of AB. And again, notice how AB doesn't have the letter C in it. It doesn't include the vertex. And then, of course, we could call all of these sides little a, little b, little c. Now, this is one of the most important theorems that we're going to have ever. We're going to explore it, okay? So first we got to get through some definitions. First definition is interior angles. Those are your angles inside the triangle, meaning all of these angles right here are interior angles. Now, if we take a side of the triangle, like this side right here, and we just extend it a little bit more, we get something called exterior angles. So that's all of your numbered angles here. This 3, this 2, this 1. These are all exterior angles. They are on the outside of the triangle, but form a linear pair. Remember, we call this situation here 2 adjacent angles on a straight line. We call that a linear pair. So if we remember They are going to be supplementary. So again, your interior angles are the purple ones, and your exterior angles are angles 1, 2, and 3. And we're going to have theorems for both of those. So now, I want you to pause this video after I give you instructions, and I want you to go to Schoology. You're going to click on the Unit 3 or Unit 4 folder, and then you are going to click on, this one will be 4.1 Exploration Part 1. I want you to click on it. Also, that website that I have you go to, I can tell if you clicked on the link or not and if you did the work or not. So if you are currently still watching this video and you're not trying to open the link, you will not receive full credit in your notes. Okay? Don't just copy down my stuff. I want you to truly see what's going on. So pause the video for a second. When you click on that link, you're going to get a picture that looks like this. What I want you to do is answer all of these questions about that picture. And just remember, to measure an angle, we click the drop down on the side, we click measure angle, and then for example, if we're measuring angle B here, I'm gonna trace out that angle with my cursor. I'm gonna click point A, point B, point C, and then a little arc is gonna show up in there with a degree measure. Okay? So I want you to pause the video and come back in a few minutes when that's done so you can check your work. Okay, so if you measured all of those angles, you should have gotten that this first one was all 60 degrees. So measure of angle A is measure of angle B is measure of angle C is all 60 degrees. If you measured the second one, you would have gotten a 90-degree angle there. So this is a right triangle. And you would have gotten 36 degrees and 54 degrees. And then for your last one, you would have gotten 140, 20, and 20. So once you get all those, we can kind of start the exploration here. It says, find the sum of the interior angle measures for each triangle. So for our first one, 60, remember sum is addition. So 60 plus 60 plus 60, we get 180 degrees. For the next one, DEF, that is our 36 plus 54 plus 90. Plug that into the calculator, you would get, again, 180. Do the next one, we have 20 plus 20 plus 140. And you would, again, get 180 degrees. Taylor, you can still ask me questions and stuff. I'm just recording a video right now, sorry. So if you notice, the sum of the interior angle measures of a triangle is 180 degrees. So that's what we're going to use to write our conjecture. So it says, write a conjecture about the sum of the measures of the interior angles. We're going to say the sum of the measures of the interior angles of a triangle is 180 degrees. Meaning you add up all the inside angles and you get 180 degrees. And that leads us to our first two theorems. The first one is the triangle sum theorem. This is, again, one of the most important theorems we'll talk about. We'll use it for the rest of the year. You have to have it memorized. It says the conjecture that we just wrote down. The sum of the measures of the interior angles of a triangle is 180. So in triangle ABC here, measure of angle A plus measure of angle B plus measure of angle C, those all have to add to 180. Okay, remember in this class we're always dealing with 180 and 90. For triangles we're dealing with 180 very often. That also kind of directly proves the next corollary. Imagine that one of those angles was a right angle. Well then, if angle C is a right angle and I kind of substitute it into here, measure of angle A plus measure of angle B plus 90 is equal to 180. I would subtract that 90 over, and I would get measure of angle A plus measure of angle B is 90 degrees. So what that means is if we have a right triangle, the other two angles are complementary. They add to 180, or to 90, sorry. They add to 90, because we took the right angle out of the total 180, and we were left with 90. So let's do some practice problems. First one, determine the value of x in each diagram and then classify the triangle by its sides, by its angle measures. So anytime you see a triangle and you know all three angles, you add them up, you set them equal to 180. They always add to 180. So in this case, we're saying x plus 4x plus 20 is equal to 180. So 5x, and if I subtract that 20 over, is equal to 160. So x is equal to 32. And now I'm going to take the value I just got for x and use it to determine my largest angle measure. Well, if I look, I know 4 times 32 is bigger than 20, so that 4x is going to be my biggest angle measure. 4 times 32 is 128. That is an obtuse angle, so this is an obtuse triangle. Okay. So we had to plug it back in and then classify. For the next one, we're going to do the exact same thing. We're going to add up all of our angle measures and set them equal to 180. So 2x plus 30 plus 6x is equal to 180. If we combine like terms on the left, we get 10x. And if I subtract that 30 over, I get 150. Divide by 10. X is equal to 15. This one's harder to tell with the variables which angle's going to be bigger, but with the picture you can kind of tell more. The 6x angle is going to be our biggest angle. It looks the biggest. It's maybe acute, maybe obtuse, but it's going to be our biggest one. If we do 6 times 15, if we plug x into that 6x, we get 90 degrees. So that means our largest angle was a right angle. So therefore, we have a right triangle. Now the very last one, again, we have 3 angle measures in a triangle. We're going to add them up and set them equal to 180. Combining like terms on the left, we would get 13x minus 15 is equal to 180. Add the 15 over, you get 13x is equal to 195. Divide by 13, you get, again, x is equal to 15. This one is even especially more hard to tell which angle is bigger. So I'm just going to plug it into a random one. 6 times 15 minus 30, and see what it gets me back. In this case, that would get me 90 minus 30, which is 60. And actually, if you plug them into every angle measure, 4 times 15, that's 60. And 3 times 15 plus 15 is also 60. So that means all of my angles are congruent, which means this is an equiangular triangle with 3 congruent angles. So that's our first theorem. For the second theorem, again, I want you to pause the video. I want you to go to Schoology, and now I want you to click on 4.1 Exploration Part 2. You're going to do a very similar thing that you did for Part 1. We're just going to measure a bunch of angles and write some things we know about them. This time you're measuring the exterior angles. So that means if we're measuring this one right here, for example, I would press GIL. You're kind of tracing out that angle with your cursor. So go to Schoology. Again, I can tell if you watched the video or not, and I can tell if you are doing the exploration or not. And if you are not doing it, you will not receive notes points for this lesson, okay? So go to Schoology, do the GeoGebra link, and then come back here when you're done. Okay, if you measured all of those angles, these are the measures you should have gotten. Now we're going to kind of compare these. So our exterior angles were 120 degrees, 90 degrees, and 160. And now let's look at our interior angles. Thank you. You're awesome.
Am I supposed to do my review though?
You are. Okay. Thanks, Taylor. Have a great weekend.
You too.
Thank you. Okay, so those are our exterior angles. Now it says find the measures of the two non-adjacent interior angles. So the non-adjacent means the ones not right next to. So that's your 60 and your 60, your 36 and 54, and so on. So for triangle ABC, that's our 60 plus 60. Remember, sum means addition. 60 plus 60 is 120 degrees. Next one was 36 plus 54. That's equal to 90 degrees. And then the last one was 140 plus 20. And that's equal to 160 degrees. Now I'm going to zoom out for a second. Let's see how our answers in number 1 and number 2 compare. Well, if we look, they're the same. Our exterior angle was equal to the sum of the measures of the two non-adjacent interior angles. So that's exactly what we're going to write for our conjecture. The measure of an exterior angle of a triangle is equal, that's the relationship that we found, equal to the sum of the measures of the two non-adjacent interior angles. So that's what we found. We found that the sum and the exterior angles were equal. So that leads us into the exterior angle theorem. It says the conjecture that we just said, that angle 1 here is equal to the measure of angle A plus the measure of angle B. Angle 1 is our exterior angle, and angle A and B are the two non-adjacent interior angles. Okay? And then just another quick reminder, we also know, this is not part of the theorem, but we also know that the measure of angle 1 plus, let's call this angle 2, plus the measure of angle 2 is equal to 180. And we also know that angle A plus angle B plus angle 2 is 180. Okay, so triangles have like those three things going on at all times. You have your exterior angles, your interior angles adding to 180, and you have that linear pair right here between those two. Okay, so let's use all that information to solve these bottom ones. First one says determine the value of the exterior angle in each diagram. So remember, the exterior angle, there's the one on the outside, is equal to the other two non-adjacent angles added together. Non-adjacent meaning we could not pick this red angle right here. That's not part of our sum. It's right next to the x. We have to pick the other two on the opposite side of that triangle. So we're going to set up the equation. X is equal to 45 plus 54, and we get 99. And that's it. You can do the same thing for the next one. here's my exterior angle. Here are my two non-adjacent interior angles. So I'm going to set my exterior angle, my yellow angle, equal to the sum of those non-adjacent interior angles. I get 3x minus 15 is equal to x plus 21 plus x minus 6. And now the geometry part of this is done. I'm just going to solve here and combine like terms. So let me combine like terms on the right-hand side. X plus x is 2x. 21 minus 6 is 15. And now I'll start moving across my equal sign. I'll subtract 2x over. I'll add 15. And I end up getting that x is equal to 30. So I want you to try these 4 problems on your own. It uses the 2 theorems that we talked about today, the 2 most important ones for the entire chapter, probably. Okay, so I want you to try these on your own. Pause the video, come back when you're done, and check your work. Okay, so this first one, we have all interior angles, and all interior angles have to add to 180. So I add them up, y plus 32, and set it equal to 180. If I combine like terms on the left, I get 2y. And then I can subtract over that 32 and get 148. Divide by 2, I get 74. Next one, same thing. I have all interior angles, so I'm going to add them and set them equal to 180. Combine like terms on the left. 2y plus 130 is equal to 180. Subtract the 130 over. I get 50 on the right-hand side. And then divide by 2. I get 25. So these were both the triangle sum theorem, where all the angles add to 180 degrees. The 2 on the right are going to use a different theorem. So here we have an exterior angle now and 2 interior non-adjacent angles. Well, from our exterior angles theorem, I'll write that over here, exterior angles theorem. We have that our exterior angle is equal to the interior angle plus the interior angle. So in this case, 2x is equal to 62 plus 84. And now we just have to solve for x. 62 plus 84, that is 146. And then divide by 2, we get 73. And also just a reminder, I could plug all of these values back in and then classify my triangle. Okay? For example, if I plugged it back into this triangle, this piece would be 146, this piece would be 34, and this would be an acute triangle. Because all of my angles are acute angles. Okay, on to the very last one. Again, we have an exterior angle. And we have 2 non-adjacent interior angles. So by the exterior angles theorem, I take my exterior angle and I set it equal to the interior angles added together. In this case, I'm going to subtract x and add 5. And I end up getting x is equal to 75. So again, what we learned today is we learned how to classify triangles. Scalene is no congruent sides. Isosceles is 2 congruent sides. Equilateral is 3 congruent sides. Okay? We can also classify them by their largest angle. If all of their angles are acute, it's an acute triangle. If one of them is obtuse, it's obtuse. If one of them is right, it's a right triangle. And if they're all the same, It's equilateral. Equiangular, sorry. So we classified some. We started talking about interior and exterior angles. And then we discovered that all the interior angles of a triangle add to 180. And the exterior angle is equal to the sum of the non-adjacent interior angles. So again, I will see you guys after fall break. Have a great weekend, but you are expected to have these notes done and to at least have a semi-decent grasp on the content. Okay?